I'm going to find my, I'm going to use this flange. I've got this part called a flange, and it looks like this. So this is part of the curriculum also. This is the practice machining project that you're going to do, or that you may do, and this is the first time that they use CAM software.
Okay.
So this allows me to do a profile around this edge. It'll allow me to make a pocket. It'll allow me to do a hole profile. Or so I can do holes too. So I can do those 3 operations in one part. All right?
So profile is not necessarily around the outside. It's just a basic path, basically. I mean,
Yes.
it's the thickness of that cut, the width of the bit.
Yep. So you can do a profile. Profile means just follow a line. So I'm going to save this on my desktop. And yeah, it just means following a line. So if I follow a line, I can do it in the middle of a part. I can do it around the edge of a part. As long as I can select a line to send it around, I'm okay.
Gotcha.
So there's that. So let's say File, Open, Desktop. There we go, Flange. Okay, there we go. So there's my part. Oh, look, kid made the part wrong. PRZ's in the wrong spot. You see how my part reference zero is way in the bottom? So they really messed up it, Inventor, and that's okay. Because in HSM, you just turn it over, say PRZ, and click on that point, and you're done. I got to do it a little bit differently. I have to pick my stock. I have to find that. I'm going to call it New, Origin, through 3 points. I'm not going to do a whole lot of explaining because you'll never have to do this. But I have to put it in the right place. So there it is in the right place. I've got positive X, positive Y, and Z coming out of the screen. Blue's the Z pointing straight up. Find my features. And again, you don't have to in Inventor, because Inventor, you're already in Inventor. It knows. It has your browser right over here.
Right.
Right? So now I'm going to go into manufacturing. Okay. Select where my PRZ is. Boom. And I'm set, ready to go. So again, what do you want to do first? Profile, roughing, or holes?
It doesn't really matter, right?
Nope, doesn't matter. So let's do the holes.
Okay.
Do the holes? Because we didn't do that yet. It says select points. I clicked on one because they were all the same. It picked all of them. I know that that's a 1/4 inch hole. So I'm going to go right straight to roughing, find my 1/4 inch tool. And say, okay, and verify. I have the kids verify after every operation just to make sure it does what you want it to. Bam, there we go.
Sure.
And I have them saved now too. Let's do the pocket. We're going to choose that. Enter, let EdgeCam pick the parts, or let HSM pick what you want. Tooling, all I'm going to do is pick a tool. I'm going to use a 1/2 inch end mill. And the reason I picked a 1/2 inch end mill because that's a 1/4 inch radius and I know that tool will fit in there. Say, okay, I can go, and again, I can change the depth of cut. I can make it do it in 2 passes. I can make it do it in 3 passes, but I just want to go over the process today. So there's my pocket. Let's see what it looks like. Bam, looks good so far. So the last thing I want to do is a profile, which is the profiling tool. And another way to select, I can come over here and I can select bosses or pockets or whatever over here. Enter. In HSM, you're probably just going to go right out to the screen and pick things. The tooling for this, the tool I'm going to use is going to be the 1/8 inch end mill. I'm going to select the 1/8 inch end mill. I'm going to say OK. And now I'm going to play this. And I'm going to go pretty slow to make sure. So I drilled my holes. It goes up. It changes the tool. It makes my pocket. It goes through and it makes my outside edge, done.
So you have a tool change before every one of these operations.
Right. I did this on purpose this way so that kids have to use 3 different tools at 3 different depths, and that gives them some modeling background too, to be able to make those parts in different sketches at different depths.
So what happens if, you know, I'm guessing that profile, you said it was an 1/8 inch, so I'm guessing that was only an 1/8 inch across.
Right.
So if I tried to tell the computer I wanted to use a 1/2 inch bit or something ridiculous like that, is it going to come back and tell me problem?
Yes. It would say, no, I can't create a tool path. It won't fit.
Right.
If you picked a smaller tool, it would allow you to do it. But if you use a smaller tool, your groove would be thinner. So what I could do, if my groove is too thin, I could offset it and do another profile to make it the right thickness.
Right.
Or I could pocket it with a small, you know, so there's lots of different ways to attack it. But the idea is, go ahead.
Oh, and you picked the bit you picked for that center pocket was just so that the radius of the bit was the same as the radius of the corners. So that was basically the biggest one you could use. So that's going to get the job done the fastest. Right,
right. And this, because this was a project for kids, a first project, we did that on purpose. We made this exactly 1/8 of an inch so that you use 1/8 of an inch. And they make this part in Inventor first. So they know that that's a 1/4 inch hole. They know that that's a 1/4 inch radius, which is the same radius that a 1/2 inch tool has. And you try to teach them to maximize your efficiency so that you could do this with an 1/8 inch end mill. And if you were to do that, you would see that it would take you 20 minutes because it's taking you all your time chewing that out of there. It'll work. And if you wanted sharp corners, you could pocket it with the 1/2 inch and then take an 1/8 inch and run it around there and clean out the corners if you want.
Oh, yeah, sure. So that would be a way to get it done faster, is to kind of rough cut it with a big bit and then go in and find details with the small one.
Yeah, and I don't know if Jim showed you last week the tutorials on our website. There were some really cool tutorials, solutions under HSM, and since you're using HSM, this will be perfect. This is the only one in there. So there's a video on how to set up HSM, how to do facing, roughing up. We tried to make these so that any issue you could come across, like here's a pocket with 2 different depths, like I just did. Here's one way of attacking that. Here's a facing operation with a piece of something sticking out of it. Here's a way to attack that using HSM. It's called island roughing. How to do a contour, which is what we just did, right? We dragged a tool around a path. Multiple contours, how to do different depths. Slotting operations, so holes, different types of holes. So we went through, we tried to come up with any different thing that you could possibly, any tool that you needed to manufacture something in class, we tried to come up with a way to do it. So that's what these are. And if you were to click on this link right here, you can download the post processor for HSM that it talks about and the tool store that goes with it. You can download these Inventor files right here, and you can go right along with these tutorials if you want.
Cool.
Okay?
Yeah.
So here's this part, and now that we have the part done, it's this easy. We file, we save it, and I'm just strewing the stuff across my desktop, as you saw, and you'll see why that's a bad idea in just a minute, because the magic happens when I hit this button right here, the Generate Code button. When I hit that button, it asks me some questions like what to name it, and I say, okay. There are clashes with okay, whatever. I don't know why. No. I don't know what the heck that was. But that generates my code for me. And I had, you know how it said I had errors? The reason I have errors is because the spindle speeds, it says, are too slow for the tool that I have, for the tool that I'm using. But that's because I have a Super Pro light. It's not the machine that it thinks I'm using. You know, it's not a super duper heavy duty industrial machine that can spin at 40,000 RPM. So it just says that there's an error. I know that it's not an error. So if you do have errors, it'll tell you what they are. Here's the G&M code that you're going to teach your kids. It produces the code for you. So I'm going to say File, Save. I save my code. And then I go open up CNC Motion, which is another piece of software. I hope this license is still good. I installed it this summer. I didn't expect to get this far today with CNC Motion. So here's CNC Motion, and this is the software that we're going to use to simulate it on our machine. So I'm going to call that up, make this go away, call up one piece at a time, go like that. So this software is really kind of cool. It allows you to call in software or open up your G-code. So I'm going to say open, nope, it's not there. File, open, libraries. Again, it's going to make it hard on me, isn't it? Yep. So I'll just go here. I'll do it this way. Computer.
Now, is this CNC Motion? Is this what you use to drive your?
This is yes. Yes. This
or is this? Okay.
It's my simulation software, but it also drives my IntelliTech. So that's the advantage to having one of the only advantages to having an IntelliTech.
Well, I was going to say that it's like I know the screen. I was typing code into it today.
Oh, no kidding!
To the initial thing. Yeah.
Right. To do your testing. Awesome. So let me see if I can find my flange code. So there's my flange code. I'm going to say throw that on the desktop, and then I'm going to say File, Open, Desktop, Flange. So here's my flange code. So once I've made my code in CAD-CAM, I bring my code into CNC Motion, and then I can verify my program right here. Now, I have to warn you that I don't have my tool light. You see how it made those holes too small? Let me see why. Because my tool 2, I bet, is incorrect. So it takes a little bit of setup. Yeah, I'm not going to, I changed my tool library at school, so it's different. So it's just making those holes the wrong size. But when that happens, when your tool library is set up the right way, you tell your kids, you just go in here and you change the tool. So you change that to the right tool number, and it fixes it for you. You're done. So that's the process. The process is to go from a part in Inventor to a part in CAD-CAM to be able to actually run it on your milling machine in CNC Motion. And once I visually verify that it works over here, I can take this, download this NC code to a thumb drive, bring it over to my milling machine, and run it on my milling machine with a little bit of setup on the milling machine.
Right.
What kind of milling machine do you have in your classroom?
I have an IntelliTech.
Awesome. Perfect. So that makes this transition very, very simple. Super Pro light, or is it enclosed? Does it look like this one?
It's enclosed. It's got a shield that you pull down over it. So.
Excellent. Excellent. I think you'll really enjoy it. I think you'll like it. Everything kind of matches up, and the software just works, and I think you'll...
Yeah, dude, since we're talking about it, I got some of the wax blocks, and I ended up trying to save some money, and we bought big blocks and then cut them down, and I knew that, maybe I should wait. Is there more you need to say on this topic?
No. This is for you. This is perfect.
Okay. So at any rate, and I knew the blade width was going to make them a little bit smaller than the 2x3 inch.
Okay.
But I cannot figure out. There's like a little pneumatic. I think it's pneumatic.
Yes.
Clamp that will size to the block, and I don't know how to get that sucker to do anything. So my blocks are a little too small right now. The old ones, the one I found one to practice on that was an old one, and it just fit in real snug because it's set up for a 2x3 inch block. But mine's like 1.8 by 2.8 block, and I need to,
So there's one part that has the pneumatics attached to it, and the part that doesn't, the fixed corner.
Right.
So the fixed corner, you ought to be able to jockey around until it is perfectly the same spacing from each side of the size of your block that you have now. It should only like 1/8 of an inch adjustment one way, and then it should fit just perfect.
Right. Okay. So I don't even really need the pneumatic part to.
No,
work.
I wouldn't mess with that at all if that's the way you're. If you're, and you want to be really careful doing that too in terms of when you open there used to be a safety feature that when you open the safety shield, it would close the vise. So if your hands are in there and you open the safety shield, you just want to be real careful as you're doing it. Like if you open the vise or you open the safety shield, just keep your fingers away from the vise, and you'll get used to it. And the way your machine operates, there are ways to change that around, and you can call Teletech, and you can say, "Yo, this is not cool. Can you help me fix this?" And they'll talk you through it. It's step by step.
Well, my predecessor disabled the safety switch on the.
Oh, there's a good idea.
The hood.
There's a good idea. Wow.
He just took the little magnets off and put them right on the sensor, taped them on, so it thinks the door is closed all the time.
Oh, okay. Well, oh boy. Well, good luck with that. Huh.
I don't know if I think that was a wise move or not, but I haven't reversed it yet.
Well, when you go on and you decide to do something, see, the problem with that vise, it's nice because it's pneumatic and you can handshake with a robot and everything can be automatic. It can be all fully automated. Pardon me. The downside is that if you don't use a small rectangular block, that vise isn't going to work.
Right.
So I go to a vise that looks like this, and it's manual, but I can put that on the table any way I want. I know it's tight. I don't have to worry about, it's just once you get past the wax block size, once you get past the flange, you might want to consider buying an inexpensive manual vise because you can do parts that are bigger.
It looks a lot better, really, because of the fact a lot more of the material is exposed.
Yes. Yeah. And this is, if you look closely, you can see that there's a block of material that somebody put under there to push that up so that I could round those corners if I wanted. See, I could now round them. If I set up my machine right, I can round off those corners if I want, as long as I leave just a little bit out lip on the base that I can take over to a bandsaw and cut off afterwards. But I have a vise very similar to this, and I can move it around in my space, and I can do all kinds of things with it. It's a lot more. I think it's a lot more useful than the pneumatic one, and a lot safer with the kids too.
Yeah. So getting a vise like that, is that just?
And I can find.
There's.
All different. This is the type that I have in. I don't know why that's why my internet got slow. I disconnected it. So sorry. Come on, you can speed up now. So I've got really cheap ones like this. They cost me $78. They're not as accurate, but they do everything I need to. If I had the wherewithal to do it again, I probably would go with something more like this because this is more of a machinist vise. This is more of a vise for drill presses. It's considered a drill press vise. but this is $78. This is $230. You know, so
right.
so that's, you know, and if you have the money, and the bigger device you get, you want to make sure it's going to fit on the table, and it's going to do all the things that you want to do. But I would go to either Enco or if someplace like that. Don't go to Intelitech. They'll charge you $5,000 for it. Okay, maybe that's an exaggeration. They'll only charge you $2,000.
Okay.
For $100 vice.
Right.
But yeah, and once you decide what projects you're going to do, you know, the first year you do this, it's kind of okay. You kind of got to go on the fly, because you got to say, all right, so if I want to do this, I need this kind of vise. And I found that a 4-inch vise that has a jaws that go 4 inches, open 4 inches, I can fit that on my table, and I can hold all kinds of projects that I want to do. So I went with one like this. So if you got something like this that was 4-inch or 6-inch, something like this 6 inches long would probably fit on your table. But you want to get the dimensions of it first to make sure.
Right. Make sure I know what my table is.
Yep.
Yeah.
Yep. And then make sure you can afford it. And this will hold wax blocks. This will hold anything that you wanted to put in the machine.
And you said you had a second mill?
I do. I have two. I have a Super Pro Light and the old one that I've had since day one, the Pro Light. It looks just like this, but it doesn't have the Super on it, and it runs slower.
Okay. I thought there was a different reason. I thought maybe you had a heavier duty one, because you just mentioned they would do part of the part on one and part on another.
I have a manual mill. I think that if one of these mills goes south, if I had to buy another one, I'm really looking at the new Tormax.
Okay.
I don't know if you saw the PCNC, the Tormax 440. I think that's a new one. It's the personal. It's a personal CNC mill. It's brand new, just out, and it's fully enclosed. Check that puppy out.
Oh, wow.
Starts at $4,500.
Okay.
Compared to $32,000.
Right. I was going to say that's a lot less than the Intelitech.
Hugely a lot less. But that's just
because
I think
I'm looking at writing a grant that's specifically for Toyota's offering. I think I mentioned this last session, is offering a grant in our area specifically for SIM.
Awesome.
And I thought, you know, it would be cool to get a second one, and I've kind of talked to some people about possibly doing.
Just realize that the software is different. And then you have to have a different post-processor in HSM to output the right code for this machine.
Okay.
So once you get, I would, heck, if you can.
So it could add some complications, but then on the other hand, we would have two mills. So.
Right, exactly. But once you get the code into the machine, it's the same.
Right.
Right? It's very similar. Let's put it that way. It is harder. There are some other things that Jim can probably tell you a little bit about, because he's got a different machine in his room, and it does things a little bit differently. But if you go to solutions, I think you might be able to just type in vice. And like I said, since I've done this on my mills, I've had this vice in my mill for probably 6-7 years now. And so this is my milling machine that I can't show you. This is what it looks like.
Okay.
And it fits in there, and I can fit things up to 4 inches wide, 6 inches this way, and it works beautifully. It's not real. If I had it to do over again, I would buy a more expensive one that was more accurate.
Sure.
But like you said, you know how we talked about making it stand up in your vise so you don't hit things? That's what, I made my own parallels out of acrylic with my laser cutter. So I take those and I stick those underneath the part, and it holds it up so that it can machine this edge without hitting my vise.
Right. Okay. Well, we could use anything down there, really, right? Like.
Yeah, as long as as long as you to keep it even. Like I've used a piece of wren shape before. You know, a scrap of wood, anything that's depending on how accurate you want it to be. Machinists laugh at me for using plastic for my because it's not a true parallel, but for containers we're going to make, for everything that I do on my milling machine, to teach a kid, I'm not teaching them to be a machinist. I'm teaching them to a process. And so
Right.
I do it inexpensively. It works out pretty well. So, and that's why, again, I had no grant money at the time. This was all I could afford. So it works out for me. They're still in there. I think over the next couple of years, I have a grant. I'm going to switch them around to some better vices.
Okay. All right. So what was that other mill called? I didn't write that down. But before we go, I want to write it down.
Tormach.
Tormach.
Personal. It's called the PCNC 440. That's the newest one. It's all enclosed because, I've talked to Tormach before. Jim has people, and the biggest thing that we said, their machines aren't enclosed. And once you have an enclosed machine, you'll never go back because,
oh, really?
Yeah, all that crap stays inside. Why wouldn't you do that? And this is more open on top, but, I've got this. So I've got crap everywhere. So this would be a dream for me. I wouldn't mind this at all. But I would put a vacuum shield over the top of this and just suck the crap out of it as it comes. But yeah, I think I would definitely consider this if one of my milling machines ever goes down, because I bet for $6,000 to $8,000 I could probably beef this thing up to do some really cool aluminum projects.
Right.
And get enough tools and tool holders to have a full complement, because tool holders for this are a hell of a lot cheaper than they are for the IntelliTech. The IntelliTech, the tool holders alone are $200 plus. Okay. For one tool holder.
Well, I know I talked to some of my advisory board about possibly doing like I don't even know what it's called, but he had kind of done a home kit for some kind of router. And he, and I talked to him. I was like, do we want to do something like this where we could do like a several foot by several foot project, instead of it being enclosed? But of course, it wouldn't be enclosed; it'd be out on a big table. But
right. And they make those so that you can hook a vacuum right up to the router too, though.
Right.
So those are. I would like to get a small router too, so that you can do multiple things. But I'm dreaming.
Well, thank you very much for your time.
Oh, you're welcome. Thanks for coming. And if you have any questions this week, be sure to shoot us an email.
Yeah, I might, because I got a couple things kind of percolating at this point, but I kind of got to go right now. So
okay.
So thanks again, and I'll see you in a couple weeks, I guess.
Great talking to you. Have a great Thanksgiving, and we will see you in a couple weeks.
All right, you too.
All right, take care.
Bye.
Bye-bye.